Hello everybody, welcome to Mogajastra and welcome to class 10 CBSE. Okay, I hope you all are well and you definitely watch my previous video which are based on the real numbers. Today we are going to discuss about the polynomial and this is the first part of the polynomial. So if you give me 45 hours to complete the entire mathematics course for CBSE class 10, I will assure you that you will definitely score at least 90%. At least that means you have to score 80 out of 90. It is my guarantee. Okay. So let's begin with the polynomial. First of all, there is a brief discussion of this chapter. Then we will solve few numericals. I think this video will be bit uh, large, or its length is quite more because we are going to discuss at least 15 numerical over here in part 1, and in part 2 I hope there will be also another 15 to 20 numericals. Okay, so it means that if you practicing this 30 or 35 numericals, and you will get definitely the common for 2025. Okay, board exam. So let's start with polynomial. Okay, first of all, you know what is polynomial. So a polynomial is an algebraic expression with two or more terms, means it has more than two terms. That is, if we are discussing, if we are taking example, 2x plus 3 is a polynomial of degree 1. Okay, like that we can write down it is 2x square plus 3x plus 5. It is a polynomial of degree 2. Okay, like that we can write 2x cube plus 3x square plus 5x minus 11. This is also a polynomial of degree 3. Like this we, and so on, 2x to the power 4 plus 5x x cube plus 8x square minus 11x plus 18. This is a degree 4. So on, so on, so on. You can go for x to the power 5, x to the power 6, like this. And if a polynomial having a degree 0, you know, you have to know this, that is 5 is also a polynomial of constant term of degree 0, and it has only one term, so it is also a you can say it is also a expression, not, it is not an algebraic expression. If a polynomial having a degree 0, then it is called the constant polynomial, and it is not included in this session because we are not going to discuss anything about any natural number. A natural number is a polynomial of degree 1, degree 0. We are going to discuss about the degree 2 over here. It is very important for this lecture. And if a polynomial having degree 1 is called the linear polynomial, degree 0 is called the constant polynomial. Polynomial can be written as poly over here. Okay, so degree 2 is called the quadratic polynomial. Like 3 of degree 3 is called the cubic polynomial, means any expression having the highest degree 3. Okay, and like this for 4 it is the biquadratic polynomial. Okay, so on. Okay, so so these are the simple example of the polynomials of different kinds of degree, of different degrees. Okay, now another important term is the important thing is the value of the polynomial. That is, what will be the value of polynomial depending upon what factor. So you can say if px be any polynomial is written over poly over here, and a be any real number, then the real number obtained by putting x is equal to a is called the value of px at x equals to 1. Means px, if px is, you can say, 2x square plus 3x plus 5. Okay, and what is the value of this polynomial dependent upon the x, the value of x, whatever we are putting in this expression. Okay, so if PA means if we putting a instead of x, then it becomes 2a square plus 3a plus 5. Instead of a, if we are putting p5, that means instead of x we are putting 5, then it is 2 into 5 square plus 2 3 into 5 plus 5. It becomes 50 plus 15 plus 5, that is the 70, is the value of this polynomial, and it has a degree of 0, so it is a constant for a constant value of p. That's why it is called the constant polynomial. For constant value of p, that is 5, or you can say it can be 3, it can be 2, it can be 1, whatever it is. For that constant value we are getting some constant answer, a constant number, that is a degree of 0. That's why it is called a constant polynomial. Okay, like that, the more important term over here is nothing but the most important, that is the zeros of the polynomial. Zeros of polynomial. Everything will discuss on these zeros of the polynomial topic. Okay, everything is dependent upon the zeros. Okay, it means that 2x square plus 3x plus 5, okay, this is the polynomial, or we can say that x square minus 3x minus 4. Okay, okay, so for what value of the x, for what value px, if px is this, then for what value of p, this is the 0, that means for what value, if for what number this equation become 0. So if we are discussing, or if we are making this expression in algebraic in the factorized form, then we get its solution, and one of the solution we are getting is, you can take p of minus 1, then it becomes minus 1 square minus 3 into minus 1 minus 4. That means the 1 plus 3 minus 4, that is the 4 minus 4 equals to 0. It means that it has a value of minus 1, which is the 0 of the polynomial. That is the for what value of the polynomial, for what value of x, or for what value of this variable, this entire polynomial, it may be a quadratic, it may be biquadratic, it may be cubic, it may be linear, whatever it is, the polynomial becomes, the expression becomes, we are getting the 0 value, that is called the 0 of the polynomial. Okay, so and one thing you have to keep on your mind, that if the highest degree is 2, then we should get the 2 value of polynomial. One, we can say that alpha, and another is beta. For that alpha and beta, means if we put alpha over here, then we can get it is 0, and if we put beta over here then also we can get 0 because the highest power is 2. Like that, if the polynomial is of degree 3, that is the x cube minus 3x square plus 5x minus 8 equals to 0, it is one kind of polynomial and it is cubic polynomial. It means that x have the three different solution, that is you can say that alpha, the beta and the gamma. For alpha, if we put alpha over here then we get 0. If we put beta over here instead of x, then we also get 0. If we put gamma instead of x over here, we can get 0. So it means that the power determines that how many solutions we are getting from this after solving this polynomial. Means after solving this polynomial, how much answers we are getting, that answer should be put on that polynomial to get it 0. That's why they are called the zeros of the polynomial. Then the relation between the polynomial, there are two terms, that is the sum of zeros, and it is expressed in the term of, that is the minus of coefficient of x by coefficient of x square. And the another important term is the product of zeros, that is nothing but the constant term is expressed as the constant term by the coefficient of x square. That means, so to make it more simple, that these are the quite larger expression, so we can make it simple if we are taking some coefficient of x square and we are taking some constant. That's why the general form of quadratic polynomial is, what is the expression? It is ax square plus bx plus c is the simple or general form of the polynomial, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Okay, now we can put over here as minus of coefficient of x. What is the coefficient of x? That is the b, that is the minus b by coefficient of x square is a. Here constant term is c and the coefficient of x square is a. So it means that sum of the 0 can be expressed in the form of minus b by a, and product of the 0 can be expressed in the form of c by a. These two are the most important thing we have to know over here, and obviously we are taking the zeros of quadratic polynomial should be alpha and beta. So sum of zeros means alpha plus beta is equal to minus b by a, and this is the product, that means the alpha into beta is equal to c by a. This is the most important thing. Then one thing, again it is very important to solve some numerical, that is the, it is the remembering part, that if alpha and beta are the zeros of polynomial px, then we can write the expression px as general form is ax square plus bx plus c. This is the in the form of a, b and c. Now we are expressing this px in the term of alpha and beta, that is the sums and zeros, and it becomes k into x square minus alpha plus beta into x plus alpha beta. It means that is the k is a constant term, k is equal to constant term, and and it is expressed as k into x square minus sum of zeros into x plus product of zeros. What is the function of k? What is k? It is, you can go through an example. That means if you can say that x square plus 4x plus 3, if we are factorize this part, this is x square plus 3x minus, sorry, plus, okay, plus 3x plus x plus 3. This is the simple middle term factor. Then taking x is common in the first two terms, that is the x plus 3, and again plus 1 is common from the last two terms, it become x plus 3. So if we write it, then x plus 3 is common for these two terms. So taking x plus 3 is common, and it is x plus 1, that is x equals to minus 3 and x equals to minus 1. That means if we put, that is the, if we can say this is alpha and this is beta, these are the zeros of the polynomial, and you can put x is equal to 3 over here, you get this become 0. We can write it now as 0. So if we put x is equal to equals to minus 3, this expression becomes 0, and if we put x equals to minus 1, then also we are getting this as 0. Now what is the another, and what is the function of k? Now we rewrite this equation in the form of 2x square plus 8x plus 6 equals to 0. Okay, now we can make this middle term again, but if we taking 2 as constant, then it becomes x square plus 8 plus 4x plus 3 equals to 0, and we are factorizing this term, so this become 2 into x plus 3 into x plus 1 equals to 0. So whatever this is 2 or 3, if it is 3 into x square plus 4x plus 3 equals to 0, then also the alpha and beta, alpha is always minus 3 and beta is always minus 1. Here also put alpha is minus 3, you get this equation as 0, and beta equals to minus 1, you get the equation as 0. So whatever this term is, this is a constant, whatever the it is 2 or 3 or 4 or minus 5 or minus 6, whatever it is, the actual form is x square minus sum of the zeros into x plus product of the zeros, that is the general term of the polynomial. Now we can go through some examples. Okay, now let's start with the examples. So first is the this page. So first is the find out the zeros of the polynomial. Find the zeros of polynomial like y square plus 4 root 3y minus 15 and verify the relation between the zeros and coefficient of the polynomials. It is a very simple question. So that is the zeros, we have to find out the zeros, means for what value of that this expression becomes 0. So it becomes, so the here it is in the term form of, in the term of y, it means it is a function of y. We can say py equals to y square plus 4 root 3 y minus 15. Now we can make it simplify by the middle term factor. Okay, so 15, so 4 root 3. So if we multiply 5 root 3 into root 3, then it become 15, and if we subtract root 3 from 5 root 3, it becomes 4 root 3. Okay, so now y square plus 5 root 3 y minus root 3y minus 15 equals to 0. That means you have to find out the zeros of the polynomial. Here one thing you always keep on your mind, that these sign determines that how we can factorize, that means the how the middle term of this expression, this is the middle term, how the middle term we have to split, that is, it means it is minus, means we have to split this middle term in such a way that the difference between, that is if we subtract the smaller one with the larger one, then we get this. If this is plus sign, it means that we have to add the two factors to get this middle term. Okay, here it is minus, we have to make the subtraction over here and we get the middle term. Okay, now we are taking y as common, that is the y plus 5 root 3, again minus, it is the root 3 common, is the y plus 5 root 3. That means y plus 5 root 3 and y minus root 3. This is the expression of the polynomial. That means that is the simplest form of the polynomial. That means now we have to find out the zeros. Okay, so let us write the zeros of py is given by what? Py becomes 0. We have to find out 0. What is py? It is the y plus 5 root 3 into y minus root 3 is equal to 0. It means that either we can take any one from these as 0, then it becomes 0. So y plus 5 root 3 equals to 0. It implies that y is equal to minus 5 root 3, and again y minus root 3 equals to 0. It implies that y equals to root 3. So these are the two zeros of the polynomial. That means if you say alpha equals to minus 5 root 3 and beta become root 3. Now we can verify the sum of the 0 and the product of the 0. Okay, the sum of the 0 we can verify. First the sum of the 0. So the sum of zeros is the alpha plus beta. What is alpha plus beta? It is minus 5 root 3 plus root 3, that is minus 4 root 3. Now verify it. What is the sum of the zeros? We know that sum of the 0 is the minus of coefficient of x by coefficient of x square, that is the minus b by a. What is b over here? The b is the plus 4 root 3. It becomes, so minus sign is before b, so minus of plus 4 root 3. And what is a? Here a is the 1 because the coefficient of y square is 1, so this is 1, so it becomes minus 4 root 3. So zeros of the polynomial is satisfied by analyzing this polynomial in the factorized form. Okay, now we are going to verify the product of the 0. Okay, the product of zeros is equal to alpha beta. What is that alpha beta? It is the minus 5 root 3 into root 3, that is the minus 15. Now what is the product of the 0? It is the coefficient, constant term by coefficient of x square, that is the c by a. What is c over here? C is the minus 15. What is the coefficient of x square? That is the, or y square, here it is y square, it is 1, so it becomes minus 15. So this and this satisfy with this, and this minus 4 root 3 and minus 4 root 3 is satisfied by the sum of the zeros. I hope you understand this. Now go to the second numerical. Find out the zeros of the polynomial of 2x square plus 7 by 2x plus 3 by 4. Okay, again I am taking this example because these are quite different, because you are not going to get the simple middle term factor. Rather than you are getting the some root, the middle term factor containing some root, or the middle term factors containing some the fractions. Okay, so here it is the, it is a function of x, so we can write it is a px. So px is what? 2x square plus 7 by 2x plus 3 by 4. Now take, now we are going to factorize this. Okay, now just simple add it. So the uh, denominator is 4, it is the 8x square plus 14x plus 3. Okay, now take out 1 by 4. Now it is 8x square plus 14x plus 3. This is nothing but the k, that is the whatever the, if we are make this simplify, that is if we are middle term factorize this polynomial by middle term method, whatever the zeros are coming, that and the 1 by 4 into this expression have the same zeros. So we have to middle term, make it middle term, 1 by 4. Okay, 8x square, that is the 4 8x square plus 12x plus 2x plus 3. Now 1 by 4, take it as it is. So here it is 4x common, then 2x plus 3 plus 1 common, 2x plus 3. Now it is 1 by 4 into 4x plus 1 and 2x plus 3. Okay, this is the middle term factor of this given polynomial. Now, so we have to make it the zeros, px should be 0, because we have to find out the px, the zeros of the polynomial. So it means that this is 4x plus 1 and 2x plus 3 becomes 0. So it becomes 4x plus 1 into 2x plus 3 becomes 0. Now it becomes 4x plus 1 equals to 0. It means 4x equals to minus 1, then x is equal to minus 1 by 4. Like that, 2x plus 3 is equal to 0. So 2x equals to minus 3, then x equals to minus 3 by 2. Okay, so minus 3 by 2 and minus 1 by 4. So we can take it as alpha and we can take it as beta. Now find out the sums and the product. Okay, so find out alpha plus beta. What is alpha plus beta? Minus 1 by 4 plus of minus 3 by 2. That means the 1 by minus 1 by 4 minus 1 by 4 minus 3 by 2. LCM is 4, minus 1 minus 6 means minus 7 by 4 is the sum of the zeros. Okay, now from here we can make it. So it is the coefficient of x is x square is 2, coefficient of x is 7 by 2 and constant term is 3 by 4. Now sum of the alpha plus beta is nothing but the minus of b by a. What is my b over here? It is the 7 by 2. Okay, minus 7 by 2 by what is a? A is 2, so it become minus 7 by 4. So sum of the zeros is matched over here. Now going to the product of the zero. Okay, now alpha into beta. So what is alpha into beta? So alpha is beta, alpha into beta is nothing but the c by a, that is the constant term by the coefficient of x square, that is, what is c over here? C over here is 3 by 4. And what is a? A is 2, that is the 3 by 8. Okay. Now what is alpha plus beta over here? Alpha into beta over here. So this is alpha into beta over here is nothing but the minus 1 by 4 into minus 3 by 2. That is the minus minus plus 3 into 1 3 by 4 into 2 8. So 3 by 8. So these are the alpha beta, that is the product of the polynomial, is also matched. Very simple question. Now go to the third. Find the same zeros of the polynomial again, but here it is the quite different because it is a quite big term. Okay, and verify the relation between the zeros and coefficient. Okay, simple numerical, don't worry. So it is s, so it become, we can write it, sorry, so we can write it as in the form of px s. So what is ps? Ps is nothing but the 2a square minus 1 plus 2 root 2 into s plus root 2. Now we have to simplify it. Okay, it is a very simple method, don't worry, just multiply it. So 2a square minus 1 into s plus minus minus 2 root 2 into s 2 root 2s plus root 2. Now take common, it means that it is ready made, it is factorized. So it is s, taking s common, 2s minus 1, and here it is, we can take root 2 common, it is 2s minus 1. So it become 2s minus 1 and s minus root 2. Now as px polynomial, you have to find out the 0, px becomes 0, that means 2s minus 1 into s minus root 2 become 0. So taking 1 by 1, 2s minus 1 becomes 0. So s become half, and again s minus root 2 becomes 0, then s become root 2. Okay, so the zeros are, this is the alpha, this is the beta. Now we can verify alpha plus beta. So alpha plus beta is what? From this expression it is 1 by 2 plus root 2, that is, we can take it simple, plus 2 2 plus 2 root 2, that means it is not 2, it is 1 plus 2 root 2, it become 1, 2 into 1 2, sorry for the mistake, 1 plus 2 root 2 by 2. Okay, that is, we can now write it in the form of, okay, now we can write this, alpha plus beta is equal to minus b by a. What is b over here? It is 1 plus 2 root 2 and minus is there, so coefficient of b is minus of 1 plus 2 root 2. Okay, so that is, coefficient is comes along with its sign. If it is minus 2, then the constant term is minus root 2. If it is minus 2s square, then the coefficient of s square is minus 2. So here the coefficient of s is minus of 1 plus 2 root 2. So minus of 1 plus minus of minus 1 plus 2 root 2 by coefficient of a is 2, that is the 1 plus 2 root 2, minus and minus become plus by 2. So this is the exact form for the sum of the zeros. Now product of the zero is alpha plus beta. Alpha plus beta is nothing but the c by a. What is the constant term? C is root 2. What is the constant, what is the coefficient of s square? It is 2. So root 2 by 2 become 1 by root 2. 1 by root 2. Okay, or we can say it as root 2 by 2. Now what is alpha plus beta over here? This s is, one is half and another is root 2. That is the, sorry, here again I have got a mistake, it is alpha into beta. So alpha into beta is nothing but the half into root 2, that is the root 2 by 2. So product of the zeros is also matches with the previous one. So this is type 1 math. Now go to the type 2 math. That is the sum and product of zeros of polynomial are given. Find the polynomial. That is the sum and product of the zeros. That is the alpha plus beta and alpha beta are given. We have to find out the exact polynomial. That is the for what polynomial the alpha plus beta and the alpha beta are the given terms. Okay. Now the find the quadratic polynomial, the sum and product of whose zeros are root 2 and minus 3 by 2, also find respectively also find the zeros. It's a very simple question. That means here, that is the alpha plus beta is given as root 2 and alpha beta is given as minus 3 by 2. So what is the method to solve this? The method is here, this is the exact formula for the finding the polynomial. That is, if the sum of the zeros and the product of the zeros are given, then the polynomial is x square minus sum of the zeros into x plus product of the zeros. This is the exact formula for getting the polynomial. So here sum of the zero is alpha plus beta and this is the product of the zeros. So formula is it is the px become k into x square minus alpha plus beta into x plus alpha beta. Okay. Now k, what is x square? X square is here x square minus alpha plus beta is root 2 into x plus alpha beta is minus 3 by 2. Now we can make it more simple, that is we are just going to add it 2x square minus 2 root 2x plus or minus 3, that is we are taking k by 2 out, then it becomes 2x square minus 2 root 2x minus 3. This is the polynomial. Okay, so this is the quadratic polynomial, but the actual quadratic polynomial is 2x square minus 2 root 2x minus 3. This is the answer, and k by 2 is the constant term, so we cannot consider this constant term. We are neglecting the constant term. Okay, now we are going to find the zeros. Okay, now so to find the zero we have to simplify this polynomial. So it is 2x square minus 2 root 2 into x minus 3. Now we have to factorize this. So it is 3 into 2 6. We have to make it 6 and the middle term is 2 root 2, and we have to split 6 in such a way that the difference between two number is 2 root 2. Okay, because here the minus sign is there. So if we split 6 into 3 root 2 and root 2, then 3 root 2 into root 2 becomes 6, and if we subtract root 2 from 3 root 2, it becomes 2 root 2. So it is 2x square minus 3 root 2x plus root 2x minus 3. Then we are taking root 2x common, then it becomes root 2x minus 3 plus 1 common, root 2x minus 3. Okay, then again taking root 2x minus 3 common, the rest is root 2x plus 1. So the zeros of the polynomial is means that is the you can say it is the fx, because we are already taken px. So now fx become, we are taking fx as this, because px is this polynomial along with the constant term, and we are neglecting the constant term. That's why we are writing fx as 2x square minus 2 root 2x minus 3. So we have to find out zeros. It means that fx should be equal to 0. it means that root 2x minus 3 into root 2x plus 1 equals to 0. Taking 1 by 1, making 1 by 1 0, that is the root 2x minus 3 equals to 0. So x become 3 by root 2, and obviously taking root 2x plus 1 equals to 0, x is equal to minus 1 by root 2. That is the alpha is equal to minus, sorry, not minus, it is 3 by root 2, and beta become minus 1 by root 2. These two are the zeros of the polynomial. If we put 3 by root 2 or minus 1 by root 2, then this equation become 0. We are getting 0. Okay. Now second question, find the quadratic polynomial, the sum and product of whose zeros are minus 2 root 3 and and minus 9 respectively. Also find the zeros. Very simple question. That is the, here also alpha plus beta, just change the color of the pen. That is the alpha plus beta is equal to minus 2 root 3 and alpha beta equals to minus 9. Okay. Now what is the polynomial? Px become k into x square minus alpha plus beta into x plus alpha beta. This is the general formula or formation. Now that is the k into x square minus of minus 2 root 3 into x plus of minus 9. That means k into x square plus 2 root 3x minus 9. This is the expression, this is the polynomial, our desired polynomial, that is the x square plus 2 root 3x minus 9. So if x is equal to x square plus 2 root 3x minus 9, to find out 0 we have to solve this by the middle term factor. So here 9 into 1 9, we have to split 9 in such a way that here minus sign is there, so we have to split 9 in such a way that the difference between that two factor is 2 root 3. So we can make it 3 root 3 and root 3. So 3 root 3 into root 3 become 9, and if we subtract root 3 from 3 root 3, it become 2 root 3. So it is x square plus, we can change the again color of the pen. So x square plus 3 root 3x minus root 3x minus 9. So this become x. We can take uh, we can take uh, we can take root 3 common, or we can take x common, just simple x common, x plus 3 root 3 and minus, again taking root 3 common, it become x minus plus 3 root 3. So it is x plus 3 root 3 and this is x minus root 3. Now we have to find out the zeros, that is the, we have to make this fx is 0. What is fx? It is nothing but the x plus 3 root 3 into x minus root 3. Okay. Now taking 1 by 1 0, x plus 3 root 3 becomes 0. So x equals to minus 3 root 3, and second part is x minus root 3 is equal to 0. So x equals to root 3. Okay, these are the two desired zeros, that is, this is alpha, this is beta. Okay, so the answer is the polynomial is x square plus 2 root 3x minus 9, and the zeros are alpha and beta are the minus 3 root 3 and root 3. So go to the next type 3. The polynomial given have some unknown terms, zeros are also given. Find unknown term means the polynomial is not a exact simple polynomial. There is some term which is not known to us. We have to find out that term, put that term and make it a real polynomial. Like the here we are dealing with a quadratic polynomial, so it becomes obviously quadratic polynomial. So the polynomial given over here is px is equal to ax square. So px equals to ax square minus 3 into a minus 1 into x minus 1. So here we have to find out the value of a and find out the unknown term. That is we have to find out the a. Okay, so it means if 1 is the 0 of the polynomial, so it means one 0 is given, that is p of 1 equals to 0, because 1 is the 0. That means putting 1 as 0, we get this term as 0. That means we write p1 become, instead of x we are writing 1. So a into 1 square minus 3 into a minus 1 into 1 minus 1, that is the a minus 3 plus 3 minus 1, that is the uh, this is the 3 into, sorry, 3a. So this is the minus 2a plus 2 2. So it is nothing but the 0, because the if we put 1 instead of x, then the polynomial becomes 0, because it is given that 1 is the 1 is a 0 of the polynomial. So this becomes 0. We have to write this implies sign, so it becomes 0. So 2a is equal to 2, that means the a equals to 1. So if we put a as 1, then this equation becomes the means the, if we put a as 1, then we get some equation, that is the equation become x square minus 3 into 1 minus 1 into x minus 1, that is the x square minus 1. So for that you put 1 over here, 1 square minus 1, 1 minus 1 is equal to 0. So obviously 1 is the 0 of the polynomial. We again back calculation, by back calculation we can prove it, that is 1 is the 0 of the polynomial. If the value of a is 1, then this become a polynomial, and the polynomial is x square minus 1. And if it is a polynomial and that is x square minus 1, then its 0 is a. So go to the next. If 0 of the polynomial is x square plus px plus q are 3 and 2, find the values of p and q, write the polynomial. Simple question. That is the, if the zeros of the polynomial is 3 and 2, that is the, if we apply p is equal to 3, then x square plus px plus q becomes 0, and if we put p equal to 2, then also x square plus px plus q become 0. Okay, this is the meaning of the first line. That means if we write fx is equal to x square plus px plus q, and alpha is equal to 3 and beta is equal to 2, then we can say that this satisfy, because alpha because 3 and 2 are the zeros of this polynomial. Now we can write alpha plus beta is equal to minus of b by a, that is the alpha plus beta means 3 plus 2 is equal to minus b means here minus of p by a means coefficient of x square is 1. So 3 plus 2 is equal to minus p, that means p is equal to minus 5. So find the value of p is value of p is minus 5. Now we have to find out the q. That is how we can write, we can find out the q. The alpha into beta is equal to c by a. What is alpha beta? 3 into 2 is equal to what is C? Q, because to find out Q we have to write I present in such a way that where C exists, Q by A is the 1, that means the Q is equal to 6. So P become minus 5 and Q become 6. This is the third type. Now type 4. Hopefully I'll stop after this numerical, because already it is, I think it is exceeds 30 minutes. So in the next video we are going to discuss the type 5, that is the find out the type 5 is the zeros or some conditions of them are given, and we have to find out the alpha, beta, k, p, all these unknown terms. Okay, these are the very important, and you will get 1 marks from that, 1 or 3 marks from that portion. Okay, so type 4 is only very simple, and we are taking only one example. The zeros are given, find the polynomials. Okay, that means zeros are given, the 3 plus root 5 and 3 minus root 5, these two zeros are given. It is 2 marks question, and find out the polynomial. Okay, hence you have to find out, say again the same thing, that is the x square minus sum of the zeros into x plus product of the zeros. That means alpha is equal to 3 plus root 5 and beta is equal to 3 minus root 5. So to find out polynomial, again I am telling you, to find out polynomial, the expression is, the formula is px is equal to k into x square minus alpha plus beta, that is the sum of the polynomial, into x plus alpha beta, that is the product of the polynomial. So to find out the polynomial, we are going to find out the alpha plus beta. It is the 3 plus root 5 plus 3 minus root 5. Root 5 cancel out, it becomes 6. And again we have to find out alpha beta. Alpha beta is 3 plus root 5 into 3 minus root 5, that is the a plus b into a minus b, that is the 3 square minus root 5 square, that is the 9 minus 5 is the 4. Now put over here k into x square minus alpha plus beta is 6, 6x plus alpha beta is 4. So k x square minus 6x plus 4 is our desired polynomial. So the answer is x square minus 6x1 plus 4. So I am stopping over here. Now in the next video we will discuss about the type 5 mathematics, that is the alpha, beta, k, p, all these things we have to find out. Okay. So for that, you keep learning and you stick to my new video series. It is the give me 45 minutes, I will 45 hours, I will give you the 90 marks. I am assuring you, you stick to these videos and you will score at least 90% in your upcoming exam. So see you in the next video. Good night.